Hello everyone, I'm Professor S.R. Patil, Department of Information Science and Engineering, PLDA CET, Vijaypura. In this lecture, I'm going to teach you memory allocation functions in C programming. So we'll see what is memory management, what are the memory allocation functions in today's lecture. So move on to the first slide, memory management, or we can call it as a memory allocation. So what do you mean by memory management? The programmer needs to allocate the computer's primary memory to store and process the data to solve a problem by using the computer. So here the programmers makes use of the following two techniques for the allocating the memory. So the first technique is compile time memory allocation. So this compile time memory allocation can also be called static memory allocation. The second kind of memory allocation technique is dynamic memory allocation. So dynamic memory allocation can also be called runtime memory allocation. So in detail, we can see how the compile time memory allocation and dynamic memory allocation works. So coming to the first one, compile time memory allocation. So we'll see what is compile time memory allocation. As the name implies, the process of allocating the computer's primary memory well in advance before the execution of statements from executable part of main function in the declaration part is called compile time memory allocation. Okay, so this technique has the following limitations. So what are the limitations it has? We'll see one by one. So here the first limitation is the allocated memory is limited in size that cannot be varied during the program execution. For example, once we allocate the size, okay, that is limited. So if the programmer needs additional memory for that, then using this compile time memory allocation, we cannot able to vary it during the program execution. That is one we can say drawback or limitation. The second limitation is an array size must be defined with fixed size. Okay, that is the size cannot be changed during the program execution. For example, if you would have given the array size 10, okay, so 10 will be fixed. Okay, so later if you want to extend to 20, okay, you cannot able to do that. So size cannot be changed during the program execution. So this is one of the limitation of the compile time memory allocation. Then what is the third one? Programmers cannot create abstract data types, that is ADT, like linked list, trees, graphs. So these all are what? These all are the abstract data type. So programmer cannot create these ADTs in compile time memory allocation. Understood? So this is the brief introduction about what are the limitations of the compile time memory allocation. All these limitations can be solved by using the dynamic memory allocation technique. So to overcome this, so we are going to make use of the dynamic memory allocation. So how dynamic memory allocation works? Okay, but as I told you, dynamic memory allocation can also be called runtime memory allocation. So here the process of allocating the required number of memory blocks during the program execution is called dynamic or runtime memory allocation. Listen carefully. It's the process of what? Allocating the required number of memory blocks during when? During the program execution. Okay. So this is called dynamic memory allocation. Memory allocation functions. So the alloc.h or stdlib.h. This is standard library function and this is a alloc.h header file. This file is having number of memory allocating functions. So we have the memory allocating function malloc, calloc, realloc and free. So this is one of the important topic in C programming, that is dynamic memory allocation. So we'll see one by one how malloc works, how calloc works and how realloc works and how free works. So move on to the first one, malloc function. It allocates the required number of memory blocks during the program execution and returns the address of first memory block. What it does, it allocates the required number of memory blocks, okay, during the program execution, and also it returns the address of first memory block. Okay, so the other address of next allocated memory blocks can be obtained by addition operation with a pointer concept. Okay, so pointer means what? Pointer is a variable which stores the address of another variable. In case of failure of memory allocation, the malloc function return a null value. Okay, suppose like the based on user requirement, we are going to allocate the like memory during the program execution. In case of failure of memory allocation, malloc function which returns the null value. So the syntax for the malloc is, this is very important: pointer, data type, malloc, byte size, where pointer is valid pointer. Okay, the data type is valid data type of which type memory could be allocated. Okay, and malloc is a function, and byte size is total number of bytes. Okay, what is byte size? That is a total number of bytes. So we can see one example, that is a programming example for dynamic memory allocation by malloc function. Okay, so this is a header file stdio.h, conio.h, and listen here. We have used the alloc.h because we are going to use the malloc function here. So where is the malloc function? So malloc function is here, right? So because of we are using the malloc function, that is why we are used the header file alloc.h. Okay, the program execution, that is start from the void main. Okay, so whatever the variable which I'm going to use, I'm supposed to declare here. Okay, I have done that. Then enter the value of n. Okay, so just look at the output, enter the value of n. I'm supposed to enter the value 5. So for that I need to read the value. So scanf statement. Okay, so IP, that is, this is a malloc function. Okay, so int star malloc n into size of int. Okay, here return type is integer and size you have given, and how the malloc function works, that we can see. So when we do this, okay, again we are asking the enter value. Okay, so enter the value. What are the value we are supposed to enter? That is, we are supposed to give. So how many number of value you have given here? We have read n is equal to 5. So we are supposed to give 5 value. Okay, so 5 value supposed to be read by the keyboard. So this for loop is for reading the all the 5 values. So this scanf, that is for the reading the values. Here listen, enter 5 values: 10, 20, 30, 40, 50. So this particular for loop and scanf perform the operation reading the all the 5 values. So I'm supposed to display all the 5 values whatever I have read from the keyboard. So this is a statement for loop and printf. Okay, so this is like memory or 5 memory allocation has been allocated to store all these 5 values. Okay, 10, 20, 30, and 40, 40 and 50. Finally I need to free the memory. Okay, so allocating, that is done by the malloc function. So I have allocated the memory and I have stored the values in that. Finally, after storing, after processing, I am going to free the memory using this free function. So we'll see what is free function and how it works in the next slide. Okay, understood this malloc function? Okay. The second function, that is calloc function. So what calloc function does, it allocates the required number of memory blocks during the program execution, okay, and returns the address of first memory block. Understood? Okay, here the other address of next allocated memory blocks can be obtained by addition operation with a pointer concept. Okay, the calloc function initializes the allocated memory block by 0, whereas malloc stores the garbage value. This is a difference. I'll repeat once again. The calloc function initializes the allocated memory blocks by 0, whereas malloc stores garbage values. Okay, so this is a syntax for the calloc function: pointer, data type, calloc, n comma byte size, end with the semicolon. So where pointer is what? It is a valid pointer. So data type is what? valid data type. It can be int, char, float, double, whatever. Kalloc, this is a function, and n is what? Number of memory blocks required, where n is what? Number of memory blocks required. So we are going to mention the how many memory blocks required here, that number. Okay, so byte size is what? Total number of bytes. Okay, so this is the Kalloc function and syntax of the Kalloc function. So now we can see one programming example for the dynamic memory allocation, that is by Kalloc. So these are the three header files, wide main. Then here we have the enter the value of n. Okay, again I'm reading the value, that is 5. So what is this function? Just look at over here, IP int star Kalloc n comma 2. Okay, so this is a Kalloc function. So I need to enter all the 5 values. For that, this statement for loop. So I'm entering the 5 values 10, 20, 30, 40 and 50 here. Okay, so finally I am supposed to print all the 5 values. The values are, so this for loop, that n value what? N value, that is 5. It means that it is keep on iterating. Okay, I is equal to 0th position, 1 position, 2 position, like that. Okay, so finally I'm going to print all the 5 values 10, 20, 30, 40 and 50. Finally I am free the memory. Okay, so this is same as a malloc function. The only difference is that, okay, here I am using the, instead of malloc, I am using the Kalloc function. Understood? Okay. The third memory allocation function, that is realloc. Realloc means what? The name itself will tell. This is another memory allocation function available in alloc.h. It helps the programmer to allocate new memory space. Okay, what is this? It allocates the new memory space for the previously allocated memory by malloc or Kalloc. Imagine that already the memory has been allocated by the malloc function or Kalloc function. So I need to have the like updation or a manipulation in that. So to do that, I'm going to allocate a new memory space by using the realloc function. Okay, so we can see the syntax: pointer realloc pointer comma new size and with the semicolon, where pointer is what? It is a address of previously allocated memory. What do you mean by pointer? What it does here? It is what? Address of previously allocated memory. Okay, realloc is a function. Okay, pointer and new size. New size is nothing but new memory space needed in terms of bytes. Okay, so what is this new size? New size is what? New memory space needed in terms of bytes. So we'll see one example. So obviously your header files will be there. So int star p, what is this? Integer pointer. Okay, int n, this is a normal declaration, initialization, not initialization, declaration. Enter the value of n. So I'm going to read again n value 5. Okay, reading using the scanf statement. So I'm using the malloc function as well here. So 5 memory blocks are allocated. So why I have given, I have entered the n value is 5. So that is why using the malloc function, so total memory blocks that are allocated, how much? 5. Okay, so now I need to like update the value. For example, I need to change from memory block that is 5 to 7. Imagine that a program is required, okay, 2 more memory blocks. Okay, so what happens? Enter the new value of n. Okay, I'm going to read the new value. What's the new value? 7 I have read here. Okay, so here ip is equal to realloc function. Okay, pay attention here. Realloc ip, this is the syntax: ip comma n star size of int. Okay, this is a function I'm using. So how many memory blocks I'm going to allocate it? 7. Okay, so 7 memory blocks are allocated. Understood? So before it was 5. Now the based on the user requirement, okay, I'm going to allocate 7 memory blocks. Okay, it means that I'm reallocating the memory blocks using this realloc function. Then the last one, free function. What it does, free function? So free function, it deallocates the dynamically allocated memory by malloc, Kalloc or realloc function. It's very simple. So whatever the memory which has been allocated from this all these three functions, so it is deallocated by the free function. The programmer needs to deallocate the memory allocated by dynamic memory allocation technique explicitly. Okay, so this free function, what it does, it deallocate the memory. So what is the syntax? pre-pointer. Okay, so this is a syntax for the pre. Then one more concept here is the preprocessor. Okay, in most of the programming, okay, we use the preprocessor directive. So what is this preprocessor directives that we can see? The preprocessor is another feature of the C language. Okay, so the preprocessor can be defined as a small program. What is this? It is a small program that runs before the compilation of main program. Okay, and just try to understand this. So which runs the before the compilation of the main program. Okay, all the preprocessors begin with what is the symbol? Font or a hash. We call it as a hash symbol, and do not end with the semicolon. This is very important. Don't put semicolon in front of the preprocessor directives. Okay, so it always start with what? Hash symbol, and it do not end with the semicolon. The hash include and hash define. So these all are what? Excuse me. So these all are hash include and hash define are the these two. One second. Sorry for the interruption. Okay. So I was talking about the preprocessor directives, right? Okay, pre got over the preprocessor. So in this preprocessor, all the preprocessor like begin with the hash symbol and do not end with the semicolon. The hash include and hash define are the most commonly used preprocessor directives. So we'll see what are the advantages of preprocessor directives. So the advantage of the preprocessor directives are written programs are easy to read. Okay, this is the first advantage. Then second advantage is that written programs are easy to modify. Okay, then third advantage is that written programs are easy to portable. Okay, portable means what? We can write, if you are writing the program in one system, okay, that can be run on the another system as well. Okay, so it is portable from one machine to another machine. So there are what advantages of the preprocessor. So there are types of the preprocessor are there. So macro substitution directives, in this simple, argumented, nested. Then second one, file inclusion directives. Then third one, compiler control directives. So we'll see one by one. Okay. What is the first one? The first one is macro substitution directives. These are used to replace an identifier or symbolic constant with equivalent string. Okay, so macro substitution preprocessor directives, that is, it is going to replace an identifier or a symbolic constant with equivalent string. So again, as I told you, there are three classifications: simple, argumented, nested. Okay, so we'll see example for each, then you will get to know. Okay, so these are used to define symbolic constant by using the hash define directive. So this is a syntax for that: hash define, identifier, and equivalent string. Okay, so here we'll see one example on this. Okay, pay attention. This is an example for the simple, and this is for macro, and this is for nested macro. Okay, so we'll see the first one, simple: hash define n 100. Okay, hash define max 50, hash define min 0, hash define pi value. Okay, pi is 3.151452. So when I define hash define n 100, so the 100, the n value will be 100 throughout the program. Are you getting? So when you define pi 3.1452, okay, this value will be remains. So this is a constant. Are you getting? So next example for the macros with arguments. So macros with arguments means hash defines square of x. What we are going to do? Macros x into x, because this is a square. Similarly, hash define cube of x. Okay, cube means x into x into x cube. Okay, so hash define maximum of a comma b. So I am going to find the maximum in this. So what is this? I am going to write a greater than b. Okay, question mark a colon b. Okay, so this is how I am going to find the maximum number using this define. Then third classification, that is nested macro. You know what do you mean by nested? Okay, so hash define m5. Okay, so here again I'm using the m value in this define hash define preprocessor directives. So that is why we call it as a nested. Okay. So how we can undefine the macro? A defined macro can be undefined by using the hash undef statement, or I can do the syntax undefined and identifier. Okay. So example, suppose you have defined the n is equal to 500. So how I am going to undefine that? That's very simple. Hash undefined n. Understood? Okay. The second classification, that is file inclusion directives. So here the file inclusion directives helps the programmers to include external header files or C files into C program by using the hash include directives. Okay, so we are going to use a hash include stdio.h, conio.h. Okay, so that is what we call it as a it include. That is by inclusion. Okay, the syntax for that is hash include file name or hash include file name within this less than and greater than. I'll tell you what is the difference between these two. Okay, so here if we use double quote to include external file, then the specified file will be searched from the working directory. Okay, suppose if we are defined within the double quote, okay, it is going to search in the working directory. If we use angle brackets, this is what we call it as a angle brackets. Okay, if we use angle brackets to include external files, then the specified file will be searched from the standard directory. Like for example, if you write c colon tc include bin, okay, so that is a directory. There we are going to search. So here example for the file inclusion directives are stdio.h, hash include conio.h, hash include p1.c, hash include p2.c. Okay, so these are the example for the file inclusion directives. Then third one is compiler control directives. Okay, the compiler control directives helps the programmers to define or undefine macros based on a given condition. So these can be used to write portable programs. Okay, so here we have the example. If def, it means what? It will test whether macro is defined or not. Hash endif, it means that it is end of if statement. Hash if and def, okay, here it means that it will test whether macro is not defined. Okay, if n def, it means that not defined. Okay, so again if the if includes you else sequence, then this is what else if sequence. Okay, so example, that is hash include define dot h, hash if end def, if not defined test. Okay, and define test one. Okay, end if. So these are some of the example for this. And we can use compiler control directive to write portable program as follows. So how we can write the portable program? If machine, that is equal to HCL or as defined file HCL.h. Okay, if it is with respect to Wipro, as defined file Wipro.h. If it is Dell, then Dell.h. Okay, they're the header end if. Okay, so these are the some of the like control directives to write portable programs. So we'll see the important questions now. You can expect the question, what is memory allocation? Explain the following functions with example. This is very important concept. You can expect this question: malloc, kelloc, realloc, and free. Okay, so all these four have the syntax and example for each. Okay, next, what are the preprocessors? Explain in brief. How many preprocessors are there? Macro substitution, again in this three are there. Then file inclusion, then compiler control. Okay, so with this quote, I would like to conclude today's lecture. Uh, do good for others. It will come back in unexpected ways. Okay, thank you so much. So kind request is that please subscribe the channel and like the video. Thank you once again.